Okay. As we look at the and one, notice how it is one single inequality. It's one problem together. I mean, you have two different inequalities in there, but they're one piece. And then if you look at the or, notice how these are actually two separate inequalities. Okay? That tells you something. If it's one inequality connected, those dots are going to connect. If they are separate, they're going to be separate of each other. They're going to be going away from each other. Okay, so let's look at the and I'll zoom in here and we'll look at example number 1. Okay, you solve these inequalities. I mean, it may look a little different, looks a little weird with two separate inequalities, but you solve them exactly the same. Draw my lines through my operations here. Okay. Now imagine this isn't here, this 3 is not here. How would you solve it? You'd add 6. And that's the exact same thing you do here. The only difference is that when you add 6, you have to add 6 to all the sides. Like I said, it's going to look a little weird at first, but it's pretty simple. 3 plus 6. 9. Inequality comes down. 3x comes down. These canceled. 8 plus 6. 14. And then what would you do? Divide by 3. Divide by 3. Divide by 3. 9 divided by 3 is? 3. So I have 3. These cancel. X. Inequality. And then 14 divided by 3. Again, when you have a fraction that doesn't go into it evenly, it's best to change it into a decimal. Which if we change it into a decimal is 4.67. And that's the answer.
I have a question.
Yeah.
When you say it was 4.67, did you already know that answer?
I knew it off the top of my head, yeah.
Like,
If you did 14 divided by 3, you'd get 4.67.
did you just now do that in your head, or did you already know from?
Well, this is the third class I've taught, so.
You know, you can't do 14 divided by 3.
Yeah, that's impossible. Okay, so now how do we draw these? Again, just like before, you have to draw a number line that includes both of your solutions. So I'm going to change colors here. And it has to just include 3 and 4.67. So I'm just going to go 2, 3, 4, and 5. Now, when I go to draw my circle, what's the first circle going to have? Open or closed?
Open.
Open at 3. So I'm going to have open at 3. And what about the second one? Open at 4.67. So this is where you got to kind of guess. You don't need to be exact, but kind of figure out whereabouts it's going to be. And then since this inequality is a compound inequality that's all one and all connected, you connect your dots. Now let's say you didn't remember that. Again, you can always check yourself by looking at the inequality. Look at the x. Is the x greater than the 3 or less than? It's greater than the 3. So I know that I'm going to shade right. And if I go over here, it's easier just to use this. Hey, if I look at the inequality here, is x less than 4.67 or greater? It's less than. So I know I'm going to shade to the left. So shading right, shade left. You know that it's connected.
Why does yours look like that?
It's a laser pointer. It's a different program than you guys have. You can pay for it. It's like $2. Okay. Now go ahead and try the second example on your own. So I did the first step here by subtracting the 5. What's negative 1 minus 5?
-6.
Negative 6. Inequality. 3x, inequality. 5, or 6 minus 5 is 1. And then what's the last step? Divide by 3, divide by 3, divide by 3. Negative 6 divided by 3. Negative 2. My inequalities do not change because I did not divide or multiply by a negative number. And then 1/3 is 0.33. Repeating. So here's my solution. So to graph it, you just need to include everything there. So negative 2, I'm going to go negative 3, negative 2, negative 1, 0, 1, 2. Now I know that I've made a number line that will include both of my solutions. So I'm going to go to draw. First one, open or closed? It is an open system. Open circle. Hey, and then the second one, closed because it's an equal to at 0.33, which is about right there. It's terrible. There you go. Okay. Now again, since it's an and, since it is one inequality that is connected together, you know that the inequalities connect. Again, it's really, really easy to check yourself and make sure just by looking at this. It says x is greater than negative 2, so I shade right. X is less than negative 3, so I shade left. Or negative 0.33, so I shade left. Okay. Now let's look at the or ones. Notice how different these ones are. They look completely different. They're in two separate inequalities. You have one inequality or another inequality. This will tell you that when you go to graph them, they're going to be going in opposite directions. Okay? In this particular one, you have to solve them separately. So I need to solve this one, and I need to solve the other one. On the left one, what do you do first? Add 3. Add 3. So 2x is less than 10, and then divide by 2. X is less than 5. So I have one of my solutions. Now when I go to do the other one, what do? Add 4. Add 4. So 4x is greater than or equal to 24. Then what? Divide by 4. Divide by 4. X is greater than or equal to 6. So there's both of my solutions. This one's pretty easy because all I have to do is include 5 and 6. 4, 5, 6, 7. First one, open or closed? Open at 5. The second one? Closed at 6. Okay, since they were two separate inequalities, the lines are going to go in separate directions. So one will go left, the other one will go right. And you can always check this by looking at your inequalities. Less than 5, so it's left. Greater than 6, so it's right. Go and try the next one on your own. So I stopped it at this point right here for this specific reason. When you get here, what are you going to need to do? Yeah, there's a kind of invisible negative 1 there that you need to divide by. So those will cancel. So I have x. Now what happens here? Yeah, the inequality is going to flip around because I divided by a negative, and that's 3 divided by negative 1 is negative 3. And now I go to graph it. I need 2 and negative 3, so negative 4, 3, 2, 1, 0, 1, 2, 3. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, so I go to graph it. First one, open or closed? open. So open at 2. And then the other one?
Open.
Open at -3. And then because they're two separate inequalities, I go in separate directions. They're not connected because the inequality is not connected. Now, you can always check your answer by going greater than 2. Yep, right. Less than 3, -3, left. Yep. Okay. Always check your answer just to make sure you're right. Okay. Go ahead and do, as we move on to the next page here, go ahead and do 1 and 3 on your own.
Maybe with number 1 be connected?
Yes. Number 1's connected. Okay. Good with these solutions?
No, not yet.
Yes.
Okay.
Okay. First one. Closed or open? And number 3. Open, you have open at -1. You have an open or closed at 2. Connected or disconnected? They're disconnected. Because the inequalities are separate from each other, that tells you, it's a hint that they are disconnected. You can always check. You have less than -1. Yep, that's left. Greater than 2. Yep, that's right. Okay, last piece. Down below, we're going to do one of these problems. Number 5. We'll do number 5. Now, those of you who have a hard copy, it's already there. Okay, it's already there, and you can start answering the questions. Those of you who are on Notability, let me give you what this is. Okay, and then you have and then okay. There is the problem for number 5. And you should be able to answer it now.
Get out of it when we're done.
Okay, hold on. Let's go over real quick. What is number 1? Conjunction. Is it a conjunction or disjunction?
Disjunction.
That's disjunction because they're disconnected. Okay. What type of inequality sign is at -2? That is a less than or equal to. And on the 0? Just greater than because it's open. And then who has the inequality? X is less than or equal to -2. Or, good, X is greater than 0. Perfect. Okay.
This was a really productive day.
Your homework is on Canvas.
Homework?